Hello, my name is HJ. Today with my teammate Rayhan, we will talk about our final project for Command Shift, HuddleUp. HuddleUp is an app for organizing meetups. The idea came from the problem that we often face when we try to organize gatherings with groups of friends and family. We often use text messaging or group chats for this, but it can be a chaotic or inefficient process. HuddleUp is an app dedicated to do that away from noisy group chats. Suppose you and your friends want to go for a meal together. You can create an event and invite friends to HuddleUp. Anyone who is invited can make suggestions as to where to have the meal and cast a vote for their preferences.
We would like to go through how we built HuddleUp. Initially, we used Figma board to lay out what functionalities we must have and also the desirable and the possibilities. We use it for making mock-ups of the app. Throughout the project, we used these as a guide and as the project developed. We frequently updated them so that they reflected what we wanted to achieve. For our teamwork, we used Slack and Google Meet on our daily basis, where we did a quick stand-up and had a longer meetings in the evening and weekends. We even used GitHub and Git to work on the same repositories with separate branches by frequently merging them to the main branch. And now I'm going to do a brief demo of the app before going into how we built HuddleUp, and we would like to give a quick demonstration of user experience using our app. This is our homepage on the web app. Now we're going to create a new user. And we're going to put the password. If you put the wrong password and try and sign up, the error will show here. When you sign up, you need to log in. When you log in, the user's name will be showing rendering up on the nav bar, and my profile will be created automatically, and then you can create an event. So let's create an event. You can choose who do you want to go with, and it's gonna be cinema. Create an event. When you create an event, you'll be able to invite your friend with this code. Now I'm gonna share the code with my other friends. Now, as you can see, a new user is logged in. We want to join an event. So now that we joined the event, we can go to my events, and you can see the movie event is here. I can suggest any movie I want. The other users can come in and vote on the movies or suggest another movie. Now a new user, Ray, came in to vote and join the events. We're going to go to my events. As you can see on my event page, we have voting finished and voting in progress. The Sunday movie voting has finished because it has 3 participants. When all 3 of them votes, it will finish and go to the voting finished section. And voting in progress, I have the Saturday brunch, so I can start voting on it. Our app worked perfectly got on mobile phone with navigation, navbar, and drop list. When you log out, you go to the home page with login and sign up page.
Now I'd like to show you how we built HuddleUp. For front end, we use a JavaScript library React with various npm packages. React allows you to build user interfaces from components, which have their own logic and appearances. So building a React app is like building Legos. So each page of our app is essentially a component or consists of several components. The user voting functionality was implemented using the user state hook in React, where various states of the voting were tracked, such as whether a place suggestion is selected by the user or how many votes a suggestion has got so far. As the user clicks to vote or unvote a suggestion, these states were changed and then subsequently, the corresponding data were updated by making Axios patch request. We also use the React context to share states across different components of our app to render them conditionally and also pass data to various components. For example, when a user logged in, the global user state is stored so that every component of the app can access that state. In our context, we use the user reducer hook, which is similar to the user state hook, but it takes a reducer function and initial state as two arguments, and returns the current state of the component and a dispatch function that can update the state when it's required. This was useful for creating event context in our app. After a user creates an event, the dispatch function updates the state as a event created, along with the data of the newly created event. The invite friends component can then use this information to generate an invite code specific for the event by hashing the event data. When a user uses this invite code to join an event, it is decrypted so that the user can be added to the specific event. We use an npm package called crypto.js for this. For our backend, we use a Node.js web framework Express.js, and as a database, PostgreSQL that is run on a Docker container. We use an object relational mapping tool Sequelize to do database manipulation, synchronization, and validation while connected to the Express app. We created a schema and models for our data so that they follow a predictable structure in the database. Users and events have many-to-many relationships, so we created a join table user events. Set up different routes or API endpoints which are then used to interact with the database using CRUD operations. These routes forward those requests to appropriate controller functions which are then used to get the requested data from the models. As all the models use essentially the same operations, we use the helper functions to reduce code repetition. For sign up and sign in, we created an auth controller which utilizes bcrypt and JWT or JSON Web Token library. When a user signs up, the user data is used to create an entry in the user table in our database. Here, we use the hash sync function of a bcrypt to hash the password in a secure way before storing in the database. When a user signs in by entering an email and a password, it searches the database for matching credentials. We use the bcrypt's compareSync function for comparing the user entered password with the hashed password in the database. When the user credentials match, an access token is generated by JWT with an expiration date and sent to the front end and used as a user context. We really enjoyed working on this project together, but also there were several challenges along the way. Working on the same repo as a team was something that threw us at the start, but we got better at it as we went along. In the front-end development, we were not sure how to pass props to siblings components, and this was solved by using context as explained earlier. Implementing voting functionality was quite a challenge because there were many states and data that needed to be constantly updated. Looking back, improving the backend and also using database aggregation with Sequelize would have been a better approach that can alleviate the heavy workload of the front end. This app has a lot of potential. For our MVP, we focused on making suggestion and voting for meetup locations only. Event dates, times, and types can also be voted on, and there could be map and calendar integration for choosing and viewing locations and dates. Other features that we can add are allowing the admin to manage events and sending alerts and messages to users. As an experiment, we also incorporated Google autocomplete functionality to our app. When a user starts typing in suggestion input box, it returns a place predictions like so. When we select the place and submit the suggestion, the place ID is stored in the database suggestion table, as shown in this output. The Google autocomplete feature was implemented using autocomplete class and its getPlace method provided by Google Maps API as places widgets. The stored place ID can then be used to retrieve location details and place them on a map. That will be the plan for the future.
We would like to say thank you to all our tutors and cohort.